today we're going to investigate simple harmonic motion and we're going to find gravity on Earth. When I was in middle school, I was always wondering what is gravity and how do we find this number? I know it's 9.81, but how do we actually find this 9.81? And I also knew that it's different in different planets, and how do people find this gravity on different planets? And today I'll show you the very simple method of finding gravity on any planet and in anywhere. And today we're going to be finding it in Houston, but with this method you can find gravity on any planet very easily. So we're going to need very simple equipment. First we're going to need a string. We're going to need a mass set. We're going to need a stopwatch. We're going to need a clamp. We're going to need a short rod around 15 centimeters. And we're going to need a 60 centimeters rod. We're going to need a scissors, a base, and a meter stick. The setup of the experiment is very simple. We're going to need the 60 centimeter rod, and then we're going to need the base, and we're going to screw that in. Then we're going to need the mini clamp and the 15 centimeter rod, and we're going to put mini clamp on top of the 60 centimeter rod, and we're going to screw that, and then we're going to use this 15 centimeter rod, and then we're going to lock it, and the top part is ready. Next thing that we're going to need is a string. We need to cut 6 different lengths of string. One of them is going to be, I'll start with 25, and I'm going to increase it by 5 centimeters. So, and you need to be careful with this tying, because since we're going to tie the string, we need to have extra 5 centimeters. So I'm going to start with 30 centimeters. And then I'm going to need 35. I am going to need 40. 45. 50. And one more. 55 centimeters of string. So we cut 6 different lengths of strings, but I'm going to use only the longest one, and I'll show you how you can actually change the length of it. So what we're going to do with this longest one, we're going to tie this one to the 15 centimeter rod, and make sure that you tie it twice, because otherwise it's going to take off. So you don't want to mess your experiment. And then we're going to, we have a mass set in here. You can use any of them in this set, but I'll just use 50 grams. And I am going to tie this from the bottom. And make sure that there are 2 nuts. Now our setup is ready. We're just going to need to change the length, and I'll show you how you're going to change this length very easily. So very important thing about measuring the length of the string. So we actually measured it with the ruler, but now we need to make sure that we are measuring the correct length. From the bottom part, we need to measure, we need to start to measure from the center of the mass. So not from the bottom, not from the top, right from the center. That's where we're going to start to measure it from. And from the top part, we need to make sure that we are measuring from right from the edge of this rod. So that is the length of the string. From the center from the bottom and from the edge from the top. And that distance must be 55 centimeters or the distance that you want. Our setup is ready right now, and it's a very simple setup. And what are we going to do with that? How are we going to find gravity from this simple setup? Here's my equation for a simple pendulum. And this is the period of a simple pendulum. That's what T is. And here is 2 pi times square root L over G. And here G is my gravity and L is the length of the string that we have measured. So what we're going to do here, we're going to isolate G, and to be able to isolate G, we need to take the square of both sides to get rid of the square root in the other side. And we're going to have T square, and we need to take the square of the whole thing on the right side. And then the next thing, we just need to take the G to the other side, and whenever we do that, we're going to have, and 4 pi squared is just a constant, so once we find the ratio of L to T squared, then we can find the gravity. In the equation, we have seen that gravity depends on L and the T squared ratio. So if we can find the ratio of the length of the string to the period square, then we can find the gravity. But to make it experimental, what do we need to do? We need to have multiple data. So that's why this is the reason why we had different lengths of the string. So what are we going to do? We're going to measure different lengths of the strings, and then we're going to measure the period for each length, and then we're going to put all of the data on a graph, and then from the slope, we're going to be able to figure out the gravity. So now our setup is ready. And what we're going to need to do is we're going to measure the period. And what is a period? It is the time that it takes to complete one cycle. So for this simple pendulum, what is my cycle? Starting from one point, making back and forth motion, and this is one cycle. But to have a better and more accurate result, what we're going to do is, instead of having one oscillation, we're going to measure 10 oscillations. So we're going to measure the period of 10 oscillation. And then we're going to divide it by 10 to have a better and more accurate result of period. So what is a period? Period is basically one cycle, time for one cycle. So what is going to be the one cycle? I'm going to release this, and it is going back and forth. So it is repeating this back and forth motion. So time to make this one back and forth motion is going to be my period. So we're going to need a stopwatch to measure the time for one oscillation. So now we are ready to conduct the experiment. So what we're going to do is we're going to measure the time for 10 oscillation. So we're just going to move it to the side by like 2 centimeters, and then we're going to count 10 oscillations. So let's get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one way of measuring the length is basically having different, cutting the string with different lengths. But there's another very simple way to do that. Instead of untying this and then tying another one, cutting different strings. Other than that, just cut one like I did. And then next thing that you need to do is you're just going to roll this around. All right, now we need to find 50 centimeters. And again, make sure that it is going to be from the edge. And now it's 50 centimeters. So we're going to take another measurement. So we're going to find the period of 10 oscillation again for the same thing. So we're going to repeat this step 4 more times, and then we're going to record our data to our data table. All right, now we're going to measure our 10 oscillation for 50 centimeters. And let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our data is 13.94. It's a little bit less, and that's what we expected. So now let's start to put all of the data that we have collected. So length, our first length is 0.55 meters. It was 55 centimeters, and make sure that you convert it to meters. And the time for 10 oscillation, we have measured it, and it is 14.75 seconds. And this is time for 10, and for one of them it's just divided by 10. So that is going to be 1.475. And then we're going to calculate the other data later. So that's what we're going to fill out for the rest of the lengths. So what we're going to do is we're going to decrease this by 5, and then we're going to be measuring the time for each, and then 10 time for each, and then time for each. And then at the end, we're going to calculate that, and then we're going to have the graph of L to T square. So let's see what we're going to do to decrease the length in the string. All right, now let's record it for the second value. So now our distance is 50 centimeters, so it's 0.50, and time is 10 for time for 10 oscillation is 13.94, and for one of them, again, just move the decimal by 1.394 seconds. All right, now let's fill out the table with the other calculations. For 45 centimeters, 10T is 13.37, so that is 1.337. And for 40 centimeters, time is 12:51. And for 35 centimeters, that is 11:64. And 1164. And last one for 30 centimeters, that is 10.73, and that is 1.073. Now, next thing that we need to do is take the square of those time values. So what we're going to do, and because we're going to need T square and L data, so let's calculate this T squares as well. And if you take the square of those T values, then this is going to be 2.18. This is going to be 1.94. This is going to be 179. And this is going to be 156, 135, and 115. So that looks like a good result because time square is supposed to decrease as the length decreases. And what we're going to do now is the plot T square and L data, and then we are going to find the slope of this graph. All right, now I have plotted the data to L to T square. And whenever we look at the data, delta L is 0.1 and delta T square is 0.4. So my slope for this graph is basically rise over run, which is 0.1 over 0.4. So my slope is 0.25. So what are we going to do with this data? We were trying to find gravity, but we found our slope as 0.25. But we need to remember our equation. We found g as 4 pi square times L over t square. So L over t square ratio is basically my slope. So instead of L over t squared, what am I going to put? I am going to put 0.25. So whenever I plot in this data, 4 pi squared times L over t squared is the slope, which is 0.25. And whenever you put all of this data, we find our g as 9.87 meters per second square, which is quite accurate because the actual g is 9.81. We found gravity as 9.87, which is pretty accurate. And all we did was measuring the time for 10 oscillation of a pendulum. And that's how easy to find gravity on Earth. And we can try this method in any other planet. We can do that in Moon, in Jupiter, or in any other planet. So that's how simple it is. Thank you for watching.